So in this week's screencast we'll be looking at how to make our own functions. So up until now we've only really been using scripts, our own written scripts, and functions that are built into MATLAB. But if we want to extend our functionality a bit further, then we need to be able to start writing our own functions. So for this first video I'm just going to go through a script example and point out some of the reasons why we'd want to move it towards a function. So the example that I have in mind we've used a few times before, and that's looking at where a parabola crosses the x-axis. So if you can't remember, the equation for a parabola is something like this. So parabola y is equal to a multiplied by x to the power of 2 plus b multiplied by x plus c. Alright, and depending on the values of a, b, and c, we get a different parabola. Alright, so let's actually make one of these. So a is equal to 1, b is equal to 3, and c is equal to -5. Alright, and let's plot this so we know what we're looking at. But to plot it we need to have some x and y values. So x is equal to linspace between -10, 10, and we'll have 100 points. I know roughly where this parabola sits, so I know the range of -10 to +10 will be appropriate enough for us to see it. As for our y values, we can pretty much copy this line, except we need to add a dot here. So x is a vector, and so it's going to be x multiplied by x, vector multiplied by vector, so we've got to have a dot here so that we do the vector dot product, not the matrix multiplication. Okay, so doing this we have x and y values, and all we need to do now is plot x and y, and when we run this I've got to save it first. You can't see it on screen, but I'm going to call it parabola.m, and I'll just dock this window. There we go. So now you can see this parabola. So somewhere around here, about +65 at -10x, goes down to its turning point about here, and then goes back up. So we can see that it crosses the x-axis a couple of times, so that's where y equals 0. Just to see that a little bit better, I'm going to add grid on to my code, and I'll run it again, and we can see we cross at about -4.1 or 4.2, and also at about 0.6, 1.1, 1.2, sorry, so that's one would be about halfway there. Alright, so we also know that, or previously touched on, that we have an equation to work out exactly where those are, and all we need to know is these values of a, b, and c. So to find the roots, I'll call them r1 and r2. So r1 will equal open brackets minus b plus the square root of b squared minus 4 times a times c, and all of that is over 2 times a. Alright, so that's our first root, and our second root will be just the minus of the square root here. Alright, we've got to change this one to root 2. Now, we might also want to plot these 2 points, so I'll put hold on, so that it's not going to get rid of our first plot when we do the second plot. So hold on, and we want to plot. Now our x points are going to be these 2 roots, so r1 and r2, and I'll put them inside of a vector, and y point is going to be 0, 0, and 0. So we're finding out where y equals 0, so the y positions of these points are going to be 0, 0. And all I want to do is draw them as a red circle. Looks something like that. Now we can run this one again, have a look at our figure, and we've got these two positions here. Now, the actual values of our roots are at about 1.19, so 1.2 and negative 4.2. So that's about what we estimated, and we've got that function. Now, this is currently a script. It's nice and easy to write, very quick, but it has some drawbacks. Basically, this workspace, we've now used these variables, and if we were to run some other script and expect these variables to be available, we have to keep in mind that they've already been used, so they're already holding values. So something might happen that we're not expecting, especially if we don't clear our variable space first. So one of the big benefits of moving towards a function is that we get our own workspace per function, so we can reuse variables a lot. We might also want to change some of these parameters, so we might want to, instead of having b equals 3, b equals 2 instead. If we ran that, I don't have my clear previous one on, so I'll just close all at the start of this. And so now when I run it, I get a fresh figure. So we may want to change these values quite readily, and to do that inside of a script, we actually have to go into the script and change the values, whereas a function, we could pass them through as an input. Okay, so I'm going to leave this video here. Next video is going to go on to where we convert this into a function itself.